Imagine the scene. The colony looks perfect. The queen is laying. Nectar intake is excellent. The bees are calm. The hive is full of life. And then one morning half of the apiary disappears into the air. Not disease, not poisoning, not starvation, but the oldest biological survival mechanism of bee swarming. And this is where most beekeepers make a huge mistake. They think the bees have gone crazy, that the problem is in the queen, that something is wrong. But the truth is completely the opposite. Swarming is a sign that the colony has reached the peak of its strength. It is not a system failure. It is the natural reproduction of a superorganism. But if you do not understand what exactly triggers swarming, you will lose your strongest colonies right before the main honey flow. In this episode, I will show you why bees enter swarming, what the real biological triggers are, how the swarming impulse develops, and why many beekeepers react too late. When we talk about swarming, most people think as if it is the decision of one bee or the queen, but the hive does not function that way. A bee colony is a superorganism, like one large living being, and swarming is actually the reproduction of that superorganism. An individual bee is not reproducing. The entire colony is reproducing. That is the first thing you must understand. Bees do not enter swarming because they want to annoy the beekeeper, not because the queen is bad, not because they are aggressive. They enter swarming because at a certain moment the biological system evaluates. This colony has enough resources to split into two parts, and that is where the whole process begins. The first major trigger is overcrowding of the hive. When the hive becomes crowded, serious changes occur in communication between the bees. The queen's pheromones no longer circulate evenly throughout the entire colony, and that is crucial. As long as the worker bees strongly sense the presence of the queen, the colony remains stable. But when the number of bees dramatically increases, while the space remains the same, an informational interruption occurs. Part of the bees receives less contact with the queen pheromone, and the system begins transitioning into swarming mode. This is why I always say, swarming does not begin with the appearance of swarm cells. Swarming begins much earlier. Swarm cells are only the consequence of an already activated process. The second huge factor is the age structure of the bees. When you have a large number of young nurse bees in the hive, but there is not enough work for them, the system enters an imbalance. That is a critical moment that many beekeepers do not notice at all. Young bees produce enormous energy within the colony. If there is not enough space for comb building, if there is not enough open brood, if there is no strong sense of work, that energy is redirected towards swarming. That is why strong colonies in spring are the most dangerous regarding swarming impulse. From the outside they look perfect, but inside, biological pressure increases day after day. The third factor is nectar intake. This is a paradox that many beginners do not understand. A strong nectar flow can increase the risk of swarming. Why? Because the bees receive a signal from nature. Conditions are ideal. And in nature, ideal conditions mean it is time for reproduction. Bees do not think like humans. Let's fill as many honey supers as possible. Their primary goal is not honey production. Their goal is the survival of genetics, and a swarm is the safest way of spreading genetics in nature. That is exactly why sometimes the best colonies are the first to enter swarming impulse. And now we come to one very important thing. The queen is not the main commander of the hive as many people think. That is one of the biggest misconceptions in beekeeping. The worker bees make the collective decision about swarming. When the superorganism evaluates that the conditions are fulfilled, construction of swarm cells begins. And from that point there is no more randomness. Then the colony gradually reduces feeding of the old queen. She becomes lighter. She prepares for flight. At the same time, the bees raise new queens. It is an incredibly complex biological mechanism. Essentially, the hive is preparing for division into two functional systems. One part stays, the other leaves. And the most dangerous mistake a beekeeper can make is reacting only when he sees capped swarm cells. At that point the process is often already far advanced. Many cut swarm cells thinking they solved the problem. But if the swarming impulse is strong, the colony will draw swarm cells again. That is why fighting swarming is not fighting swarm cells. It is fighting the biological conditions that activate the swarming impulse. And this is where we come to the essence of modern beekeeping. Your task is not to fight nature. Your task is to understand the signals of the superorganism. An experienced beekeeper often recognizes the swarming impulse long before swarm cells appear. By the behavior of the bees, by congestion at the entrance, by reduced pollen intake, by the way bees hang in clusters, by slowing of egg laying. Those are signals. The hive is always speaking. The only question is, does the beekeeper know how to read those signals? If you want serious episodes about bee biology, modern beekeeping, and the real mechanisms behind colony behavior, make sure to press subscribe and turn on the bell. On this channel we do not talk about myths and fairy tales. Here we analyze beekeeping through real biology, practice, and systemic understanding of the hive. Write in the comments, have your colonies already swarmed? And what do you think was the main reason? There is one more important thing that many underestimate: genetics. Not all bee lines are the same. Some have a stronger swarming impulse. Some are more stable. Some explosively develop the colony in spring. And this is where selection plays a huge role. Poor genetic choice can create a constant swarming problem. But even the best genetics cannot defeat poor space management. That is important to understand, because many blame the queen for the beekeeper's mistakes. And now we come to the key question: is swarming always bad? Biologically it is not. For bees it is a natural survival mechanism, but for production beekeeping it is a major problem. Why? Because the swarm takes away a huge number of forager bees, and without forager bees there is no maximum nectar intake. A colony that has swarmed often loses its main honey production potential. And this is where the beekeeper loses the most valuable resource, colony strength, at the right moment. That is exactly why professional beekeepers devote so much attention to prevention of swarming impulse. Not because they hate the natural process, but because they want control over colony development. Space management is one of the most powerful tools. When bees get the feeling of expansion, when they have somewhere to store nectar, when they have room to work, the risk of swarming significantly decreases. But it is not enough just to add another box. Timing is crucial. If you are late, the system may have already activated the swarming impulse. And then many people say, I gave them space and they still swarmed. Yes, because the reaction was not on time. Beekeeping is a game of timing. Sometimes a few days decide the entire season. Another important thing is ventilation. Overheating of the hive can intensify the feeling of overcrowding. That is why in summer you often see bees hanging outside the hive. Many think that is normal resting, but sometimes it is already a warning that the internal conditions are not good. Also, limited comb building can intensify the swarming impulse. Bees have a natural need for comb construction. When that instinct is not directed properly, the energy is again redirected toward swarming. Everything is connected, and that is why top-level beekeeping is not just open the hive and add a frame. It is understanding the biology of the superorganism. The deeper you understand bee behavior, the fewer random moves you will make. And that is the huge difference between a beginner and an experienced beekeeper. A beginner reacts to consequences. An experienced beekeeper reads processes before they explode. If this episode helped you understand the swarming impulse differently, support the video with a like and share it with other beekeepers. Write in the comments, have you ever lost a swarm right before the main honey flow, and how did it affect honey yield? On this channel we continue deeply analyzing bee biology, modern beekeeping strategies, and the real mechanisms behind every strong colony. Follow further new episodes.